Hello everyone and welcome back. What we're going to do in this video is we're going to look at disjunctions. In the last video we looked at conjunctions. We looked at where we had an inequality, where we had two inequalities with an and sign between them. In this video we're going to look at where we have two inequalities and an or sign between them. So let's just crack it open with an example. Remember, or corresponds to union. So let's just say x is greater than 4 or x is less than negative 4. Let's see what this set looks like. Well, we draw out our number line. We have the set x is greater than 4. 1, 2, 3, 4. 1, 2, 3, 4. So we have the set x is greater than 4, so we draw an open circle on 4, and then we draw an arrow to the right. So that's the set x is greater than 4. And then we have to plot the set x is less than negative 4. So I go out here to negative 4, draw an open circle, and then since we're less than negative 4, we go to the left. All right, so this is all you have to do for the ors, is you take each one, right, and you consider the union of these two intervals. So remember, at the end, with air quotes, of the number lines, we have infinities, right? So we can imagine conceptually negative infinities down here, positive infinities over here. And now what we want to do is describe the solution set with interval notation. So that means we need to union two intervals. We need to take the union of this interval and this interval. Well, let's describe what those intervals are. The first interval, the smallest number, is negative infinity. The largest is negative 4, but it's not included, so we have a parenthesis. Next, we're looking at the inequality x is greater than 4. We're looking at this right half. Well, what's the smallest number for this interval? The smallest number is 4. The largest, with air quotes, is infinity. So this is the solution set for this disjunction. So to summarize, in the last video we looked at a conjunction where it was an intersection of two sets. Here we're looking at a disjunction, or a union of two sets, and it actually forced us to put a union in our answer. That won't necessarily be the case, but in this case it worked out that way because we had this nice big break in the middle that we didn't describe in this solution. So why don't we tackle one more example. Let's take a more complicated one this time. Let's say we've got, I'll do example 8 in the text. It says that 7 plus 3x is less than 3, or 13 minus 5x is less than or equal to 3. All right, let's solve this, guys. We take each conjunction separately. We solve each of them. So, sorry, I said conjunction, but we take each inequality and we solve them separately. So we begin by subtracting 4 from each side, we subtract 7 from each side. Those cancel, and we're left with 3x is less than negative 4. And then after dividing by 3, we get x is less than negative 4 over 3. All right, that's a part of it. And remember the or. And now let's solve this one. Well, for this one, remember we have to subtract 13 from both sides. That leaves us with these canceling, and with negative 5x is less than or equal to negative 10. All right, now the last thing to do is divide both sides by negative 5. But remember, when we divide an inequality by a negative, we have to flip the inequality. So instead of this direction, it's now going this direction. And negative 10 divided by negative 5 gives you positive 2. So this right here is our solution. But what we want to do is we want to take this solution and we want to write it, we want to graph it, and then we want to write it in interval notation. So let's graph it first. That will help us write it in interval notation. So we have our number line here. Let's say, I'm going to be a little bit sloppy. Let's just say negative 4/3 is here. It doesn't have to be perfect. So x is less than 4/3. We'll graph that first. X being less than 4/3 means we draw a circle and draw an arrow to the left. Next, this one says x is greater than or equal to 2. So let's say over here is 2. If that's 2, and then we have greater than or equal to here. Notice this equals is there like it wasn't before in other examples. So now we need to do a bolded circle, a filled in circle for 2. And then because it's greater than, we go to the right. Okay, so again, we're going to imagine the infinities are on the end, and then we're going to write this in interval notation. We're going to write the solution in interval notation. So we'll focus on this interval, and then we're going to union it with this interval. So we take the left interval here, union it with this right interval. Let's do that. Well, we're going to describe the left interval as negative infinity, comma, negative 4/3. And we have to ask, do we include negative 4/3? Nope. We don't have an equal sign, so we do a parenthesis. Next, we have to union this interval, or this set, either one, with this interval, which is the interval that starts at 2 and goes to infinity. And then, remember, this one actually includes the 2 because we have this equal sign. Therefore, we need to put a bracket here. Bracket. For when it's included in the set. So 2 is included in the set, so we put a bracket. And then 2 comma infinity. And we never have brackets on infinities because we never actually touch infinity. So this is the answer right here in interval notation. So I believe that's it for this video, guys. We'll continue with this section in the next one, and then we'll be on to our first exam. So good job for keeping up this far, and we'll see you guys in the next video.